Good afternoon, guys. Can you all hear me? Am I audible?
Yes, sir.
Okay. Yeah, okay, fine. So I think people are entering. Just wait for some more time so that they can also enter the session. They will not also, they will not miss anything. Okay. Okay. Are you all safe?
Yes, sir.
Okay, good.
Yes, sir, of course.
Okay, nice. It's really nice to hear. Nowadays, it's actually important to be safe, right?
Yes, sir.
Yeah. Okay. Have you ever been to Innovation Hub in our planetarium?
Yes, sir.
Yes, sir. Yes, sir.
Okay, good. Is there anyone who attended our previous sessions on, I mean, in the previous lockdown, I think we conducted sessions on electronics and embedded system and all those things. Is there anyone who attended those sessions?
No, sir.
Oh, okay. Ah,
No,
okay.
sir.
Okay, don't worry. In that session, actually, we actually demonstrated. Oh, yes, we shall come with, yeah. Okay. So in that session, actually, we demonstrated lots of experiment here. Vishal, do you remember what we did on that particular class? Can you comment or can you just open your camera and tell something about it? Okay, others can also open your camera so that it will be more interactive. Okay, now I can only see your names and yeah, so those who are comfortable can obviously open your camera so that it will be more interactive. Okay. Okay, fine. Yes. Yeah, I can see Chotu's vlog. Yeah. Okay, fine. So in the previous session, what we did is that we actually used to conduct some experiments here, and we will actually we actually taught you about all those principles and all those experiments during that time. But later we felt that it's a bit boring because we are just doing it from here, and you guys will be simply sitting on the other side, and you will be just simply hearing all those things, right? But today what I thought is that instead of that, why can't we do something? Okay, why can't all of us do something? Okay, shall we do something different? Are you all ready?
Yes, sir. We are.
Okay. So previously we actually bought lots of components and we made lots of devices based on those components. But now what we are going to do is that we will actually work all those things. We will actually make those circuits on a simulation software, on a simulation site to be precise. Okay.
Okay, sir.
Okay, so first of all, I will just in the chat box, I will just share the link of that particular site. It is called Tinkercad. Mainly, maybe most of you, some of you might have heard it before. So we can just a second. I will just share you the link so that you guys can go there. That's the reason why I told you to have a laptop along with you. If you don't have a laptop, then also don't worry. You can do it later on whenever you have access to a laptop. Okay. Okay. Okay, fine.
Okay, sir.
So, yeah. So I have shared the link in the chat box. So you can actually click there, and on clicking, yeah, you guys can actually click there. And I will just share my screen so that you guys can understand what is supposed to be done. Okay. On clicking, actually, they will ask you to sign up. Okay, you can actually sign up using your Google account, maybe, or some other account. I think using Facebook also we can sign up. I'll just share my tab so that it will be easy for you to see how we have to do it. Just a second. Okay, can you see my tab? Oh, I think it's
Yes, sir.
coming.
We can.
Yeah, okay. So you have to just simply paste the site. Yeah, you have to simply paste the site, and it will not come like this for you because I have already signed in. That's the reason why it's coming like that. For you, you might have to sign in using your Gmail account or your Facebook account. Were you all able to sign in? Is there any
Yes, sir.
problem? Yeah, can any one of you share your screen?
Sir, can I share?
Can any one of you share your screen so that I can check that you have ended in a correct manner? Like maybe we
Actually, they are asking some code. So what should
actually.
I want to type?
Oh, don't worry, don't worry, don't worry, don't
Sir,
worry.
can you
I will.
see?
Yeah, it's fine, Vishal. It's fine, Vishal. It's fine. So, is there anyone who found any difficulty in signing into this particular site? Those who have any confusion can obviously ask me so that we can clear it. Anyone? Were you all able to sign into this particular site?
Sir,
Anjana, were you able to sign into the Tinkercad?
sir, I am signing in.
Okay, Anjana. Okay, Anjana. Take your time. Okay. Those who have any confusion can obviously ask me so that I can help you to sign in. Okay.
Sir, I am signing in a other device.
That's fine. That's not a problem. Okay. That's not a problem. Maybe you can use a computer or a laptop that will work better. Okay. It has some problem with the tablet or mobile. It will work perfectly in computer. Okay.
Okay, sir.
Okay, fine. So what about others? Were you all able to complete it? Is there anyone who require any help?
Sir, don't mind. Can you share the link once more in the chat box?
Yeah, sure, sure. Don't worry, don't worry. Just a second. Wait for a while. I will just share it now. Okay. Yeah, the link is shared again. You can just click there and you can go there. It's actually a simulation. It's like a simulation software. It's actually a site. You can go. We can actually go there, and there will be virtual components like virtual resistors, capacitors, and we can make circuits using them. Okay. Is it interesting? Is there anyone who used simulation sites before? Anyone? Oh, I hope. Am I audible? Can you all hear me?
Yes, sir.
Yes, sir.
Okay. Fine. Okay, so I hope that all of you are able to get into this particular site. Then we will just move to our first exercise. First of all, we will just simply do a basic circuit making. Okay, very simple circuit making, just to understand how we can create circuits in this particular Tinkercad. Okay, are you all ready?
Yes, sir.
Okay, fine. Okay, then what you have to do is that you have to click. Yeah, just a second. Here we can see lots of options. Like at first there is 3D design, then we have circuits. You have to click on the circuits option. Okay, then you can click on create a new circuit. Okay, but I have already created some circuits. So, but anyway, I will just create new one so that I can show you how it will look like at first. Okay, can you all see my screen? Is it visible?
Yes, sir.
Okay, cool. So, yeah, first of all, we will just make a simple small circuit. The thing is that the task is that we have to turn on an LED whenever we are pressing a switch. Okay, very basic, very simple circuit. I hope that almost all of you can do it. Okay, shall we start? What all things are required for this particular circuit? Can any one of you suggest me? It's very simple, right? What all things are required? Whenever I'm pressing a switch, yeah, obviously a switch is required. Then what else is required?
Connecting wires.
LED.
Yeah, obviously LED is required, connecting wires are required, switch is required. Then what else?
So
Cells.
Yeah, battery is required and a bulb is required. Yeah, that's nice. That's nice. You have to be responsive like this. Okay, that's really cool. Okay, so here on the right side, you guys can see lots of components listed here. So we can actually, these are actually virtual components. You can choose whatever components which we require. So at first, obviously, we require the LED. You can just simply drag it and place it here. This is our workspace. Okay. Then we require a push button switch. Then we require a resistor. Then we can choose this 9-volt battery. Okay. Okay, fine. Or we can also choose this 3-volt battery, but for now, let me choose a 9-volt battery. Okay. And now we have to rotate it, right? How we can rotate it? Either we can press on this button, which is present on the top right corner. On pressing, it will rotate clockwisely. Okay. Or you can also press on the R key on the keyboard. Okay. Then also it will rotate. And on pressing Shift plus R, it will rotate in an anti-clockwise direction. Okay. So that's how it is to be placed. Okay. You guys can also try it while I'm doing it. Okay. Or if you have any confusion, you guys can actually watch me. And after completion of the circuit, you can try it out. Okay. This is just a basic circuit, so we will try to do it as fast as possible. Okay. So now we have connected. Now we got all the components required. Okay. Now let me place all those things. So here you can see this is the positive lead. This is a negative lead. So I'm connecting the positive lead to the resistor. Maybe we can place it like this so that it will look much more better. And since it is a positive lead, I will just change the color of the wire to red according to the convention. Now then I will connect it to the switch, then to the bulb. Oh, I'm sorry, this is the anode and this is the cathode, so we have to connect it to the anode. Okay, the positive pin of the battery, it should be connected to the anode of the LED bulb, and the cathode should be directly connected to the negative terminal of the battery, and we can make it as black according to the convention. So the circuit is ready. Okay, can you all try it out? Were you all able to do it? Is there any confusion? Anyone who has any confusion can obviously ask me. It's a simple example. We will just start with this example. We have to do it fastly because we have lots of other things to cover. I just thought that we will start from a basic example so that you guys can easily understand how we have to do things on this particular user interface. Okay. Is it okay? Were you all able to do it? Anyone? Anyone had any difficulty in doing this particular task? Anyone? If you found any difficulty, you can obviously ask so that I can help you. You can actually share your screen so that I can help you help you accordingly. Okay. Those who have completed can share your screen. Okay, Sherwin, don't worry. If you don't have a laptop, then don't worry. It's not at all a problem. You can actually watch the session, and later on, whenever you have the access to a computer, you can actually try it out. Okay, don't worry. You can attend the session, and afterwards, you can try it out. Okay, is it fine? Okay, cool. What about others? Are you all doing? Okay, let's try to complete it within 325. Okay, let's try to complete it within 325. I'll just wait for some more time. Now, meanwhile, I will just show you how it works. Okay. we have actually a button on the top right corner of this particular site, which is start simulation. So you can press the start simulation button, or you can also press the S button, S key on the keyboard. Okay, then it will start simulating. Then let's check whether this bulb will glow or not. Before that, the resistance, the value of the resistance, I have chosen it as 1 kilo ohm. Okay. So you can actually change the value of the resistor here. Okay. So the value of the resistor can be changed here. Whenever you are clicking on this particular resistor, there is an option to change it. You can either choose 1 ohm, 10 kilo ohm, or whatever it may be. Normally, whenever we are purchasing these kind of components from our local market, it's really hard to get, especially the resistors of some particular values. Okay, but here it's what we can say. We can choose. We can get whatever value which is required. If we want 1 kilo ohm, then just simply type. That's ready. So that's the easiness of this particular platform. And also during this lockdown time, it's really hard to get these components because in most of the areas the shops will not be open. So it's really hard. But now everything is in your computer. You can try all those things in your computer itself, right? Is it interesting?
Yes.
Okay. Okay. Okay.
Yes.
Okay. Nice. Is there anyone? Before that, let's start the simulation. Just a second. Oh yeah, it's already simulating. Then let me press the button. Yeah. Can you all see it? Whenever we are pressing the button, the LED is glowing, right?
Yes, sir.
Yeah. So that's how it works. Now, let's check what will happen if we are removing this particular resistor. Okay. So I have removed the resistor and I have connected it directly to the switch. Okay. And let it be reddish. And what will happen if I'm pressing the switch? Can any one of you tell me? What was the purpose of that particular resistor? What will happen if that resistor is removed? Anyone? You can say anything. Okay. You don't have to worry. You can say anything.
Stop working.
Asil, can you come again? I wasn't able to hear you well.
It will stop working and it will burst.
Yeah, LED will stop working. Yeah, that's a fact. We can just try. We will just try we will actually check what will happen if we are pressing it. Let me, I think we have one more comment. Maybe the bulb burn or yeah. Yes, Sherwin. It will get burned, I think. Let's try. Oh, I think we have to start the simulation. Were you able to see it?
No.
What about now?
Yes, no.
Yeah, it got burned, right? So that's the problem. The problem is that this LED actually works on 2 to 3 volts. It cannot work on 9 volt. That's the reason why we actually provided a resistor. Resistor is a component which will actually resist the current. It will actually reduce the flow of the current. So a resistor is obviously required here on the positive terminal of the battery. Okay. And now when we are simulating, yeah, it works perfectly fine. Okay. Were you all able to do it? What about Vishal? Vishal, have you done it?
Yes, sir.
Okay. Can you just show? Can you just share your screen? Oh, Aishani, you can't rotate the battery. Okay, don't worry. Just a second. One thing you can do is that maybe is the simulation turned on in your Tinkercad? Yes, Vishal, I can see. Yeah, nice, Vishal. Nice. It's perfect. You can stop the presentation. That's really nice. It's really a nice work, Vishal. Okay. What about others? Were you all able to complete it? Were you all able to finish it? What about others? Ishani, maybe you can share your screen so that I can help you if help is required. Or I can actually show you how we can rotate a battery. I have just a second. I took a battery, placed it here. Now for rotating, we have to at first, the simulation should be anyway, should be turned off. Okay, Shani, just a second. Oh, you have selected the battery. Now you have to click on the battery and you can press on R button on your keyboard. Okay, just press on the battery. Yeah, that's it. Is it fine now?
Yes, sir.
Okay, good. So you can turn off the presentation so that I can present it again. Okay, thank you, Ishani. Okay, so that's fine. Now let's, okay, I hope that almost all of you can do it. Is there anyone who found any difficulty in doing this particular task? Anyone? Is there anyone who require any help? Let me just delete this additional battery. It's not at all required. Okay, I hope that it is fine. Now we will actually move to, we will actually study some more theory. Okay, just some theory. Okay, we will just go to the slide. Let me share my screen. Okay, is my screen visible?
Yes, sir.
Okay, cool. So we are actually going to discuss about electronics. Then we will actually slightly go to automation, and if time permits, we will actually move to robotics. Okay, so let's before going to robotics or automation, let's study about embedded system. Okay, have you ever heard about this word before? Have you ever heard about embedded system before? Anyone?
No, sir.
Okay. So the word embedded system might be a bit unfamiliar to you. Okay, but we are actually living in a world which is filled with lots of devices which works based on embedded system. Okay, let's see some of the examples. Let's see some of the devices which works based on embedded system. Okay, so yeah, automatic lighting system. Have you ever seen any automatic lighting system? Maybe you might have seen in some, what we can say, foreign movies. I mean, in some English movies, you guys might have seen that whenever some person is going to a particular room or a particular corridor, then automatically the light will get turned on. Have you ever seen it? Or even I think in our hotels, in most of the restaurants, you guys can see it in the corridors. Whenever we are walking through the corridor, the lights will automatically turn on whenever we are moving near to it. Have you ever experienced any such occasions in your life? Anyone?
Yes.
Okay, can you just explain slightly what happened there?
Actually, it was in my cousin's house. It is just a LED, not like LED. It's just a small like a bulb,
Okay.
and it is kept under the in the side of the bed. And
Okay.
when she wake up, when that sends the leg of her, it will light.
Okay. That's really great. And is there anyone who had any other experience before? Who has seen it before? Okay, fine. Then we will actually move to the other example, another example. Another one is automatic water tap. This I think you might have seen in many places. Anyone? Yes, where? Can you explain?
In a hotel.
Yeah. That's it. That's in many posh hotels you guys can see it, or in airports. I think it can be seen. Is there anyone who's seen it, who have seen it in airport?
Yes, sir.
Yeah, it can be seen in the airport. How it works? Chotu? Can you just explain how it works?
When we
Yeah, you can talk in English or in Malayalam, whatever language which is comfortable to you. Okay. What happened there? Yes. Hello. Okay, the thing is that in the case of an automatic water tap, whenever we are placing the hand just below this particular water tap, it will automatically get turned on. We will get water, right? Is it right, Chotu? Okay, I think he has some problem with his microphone or something. But that's what happens in the case of a automatic water tap. Whenever we are placing our hand just below a tap, it will actually detect our hand, and then it will automatically turn on the tap, and we will have water in our hand. And whenever we are taking our hand out of it, then automatically it will get turned off, isn't it?
Yes, sir.
Okay. Is there anyone who had such occasion, such experience in your life? Anyone? Okay. Okay. Fine. Then let's move to the next thing. Just a second. Then we have the washing machines. I hope that most of you might have washing machines at your home, right?
Yes, sir.
Yeah. We have washing machines at our home, and how it works. It actually, in the case of fully automatic washing machine, you can see that uh, we don't have to do anything, right? We have to just connect the water, and the washing machine will actually take uh, the water accordingly, right? It will actually turn on the water supply accordingly, and when the adequate water supply is reached, then it will automatically cut the water supply, and then it will start washing. Okay, so that's the case of washing machine. And then we obviously have the air conditioners, refrigerators, traffic lights. We have robotic vacuum cleaners. All these things actually works based on embedded system, and we are actually living in a world filled with embedded system. Okay, all these things are actually filled with in the case of all these system, an embedded system is actually embedded in it. Okay, so that's about the devices which are present in our daily life, which works based on embedded system. Okay, now let's move to the next slide. So here, as I was explained, let's see how a automatic vacuum pump, how it works. Let's check. Have you ever seen this kind of thing before? Automatic water vacuum pump? I think you guys might have noticed recently. I think lots of such products came to Indian market. Previously, it was actually present in the northern, I mean, America or in other countries. It was present commonly, but nowadays it's available even in Indian market also. Is there anyone who had seen it before? Anyone who have seen it before? Okay, then we will just, you can actually respond. If you are responding, then it will be quite better. It will be quite nice. It will be an interactive class. Okay. So let's move. I'll just show you how it works. So you can see that it is actually moving its own, right? Whenever it requires charge, it will automatically get charged. It will actually go to that docking station, and it will automatically get charged. And yeah, if there is any obstacle present in its path, then it will actually detect that particular obstacle, and it will actually change its path. See, that's how it works. So this device, it actually works based on embedded system. Now let's move to the other video. Okay, just a second. Let's move to the other video. Have you ever seen this robot before? Anyone?
Yes.
Okay, where have you seen it? Is there anyone who made it? Okay, this is actually a obstacle detection robot. The thing is that it will actually check whether there is any obstacle present in its path. If it is detecting any obstacle, then it will actually change its path, and it will move in a different direction. So that's how it works. So in the case of this robot also, there is actually an embedded system embedded in it. Okay, now let's move to the other video. Yeah, this, I think most of you might have seen it, don't you?
Yeah.
What is this? Can you just explain?
Line follow.
Yeah, it's a simple line follower actually. It will actually simply follow the black line which is present on the particular surface. The thing is, let's see how it works. Actually, it has some sensors below it. That is actually a infrared sensor. There will be two infrared sensors. They will actually check whether the black line is present or not, and it will actually send that particular information to a microcontroller which is present in this particular device, and that particular microcontroller will actually decide uh, the direction in which the car should be moved so that it can move along that particular black line. Okay, so that's how it works. So we have an input device which are the sensors, and we have a microcontroller, and then we have an output device, which in the case of this obstacle avoiding robot, it is a motor. And while discussing about our automatic tap, there also we will have a sensor which will automatically check, which will actually check whether we have placed our hand or not. Mostly it will be an IR sensor or a ultrasonic sound sensor or a PIR sensor. There are many proximity sensors available in the market. So it will be mostly they used to use IR sensors, infrared sensors. So that will be present, and along with that there will be a microcontroller, and the information from this particular sensor will be sent to a microcontroller, and that microcontroller will actually give some signal to the tap. There will be actually a solenoidal valve present in the, what we can say, there will be a solenoidal valve present in this particular tap, and whenever we are placing the hand, obviously the sensor will sense, and it will actually pass this particular information to the microcontroller, and the microcontroller will actually turn on the solenoidal valve. Don't worry about all these terms which I am telling. You will actually study about all those things in the future. Okay, so is it clear? Is there anyone who found any difficulty in understanding what I have said? If you have any confusion, you guys can obviously ask. Anyone? Or is it clear?
No, sir, no problem.
Okay. Meanwhile, you guys can actually turn on your camera. It will be really great because we can have a nice interaction if you are turning it on. Okay, then let's move to the next slide. Okay. So in all the previous examples, I told about an input, which is the sensors, and there will be a microcontroller, which is actually, it actually acts like a brain. It actually works like the brain of the embedded system. Then again we have an output system, and in between we have a storage space, a memory. The microcontroller can actually store some data on this particular memory space. Okay, so this is the major block diagram, or these are the major parts of an embedded system. Is it clear to you? Is there any confusion? Anyone? Is it difficult to understand, or is it easy?
Easy, sir.
Okay, cool. So now let's move to the next slide. In at any time, if you found any difficult, you can actually interrupt me anytime. Okay, don't worry. Now we are actually going to study about the microcontroller. So here we are. We have Arduino board with us. This is actually a microcontroller development board. So we will actually try to do some tasks using the Arduino microcontroller. It's easy to program. It's easy to do many tasks. We can actually do lots of tasks using this particular Arduino board. And it's a, what we can say, it's easy to use. Okay, so we have here I have shown the Arduino Uno board, and we have other different types of board also. This is Arduino Mega board, which is obviously it's large in size, and it has lots of pins. You guys can see lots of pins here. And this one is an Arduino Uno board. This has what we can say 13 digital pins and 6 analog pins here. Don't worry about the term analog pins and digital pins. We will actually study about all those things later on. Okay, so it has lots of pins. And in the case of this Arduino Mega, we have lots of pins, right? Around 55 or some, I think 54 or 55 pins are there in the case of this Arduino Mega. So this is a much more bigger version of the Arduino Uno, or it's actually more, it's actually a more bigger board. And then we have the Arduino Nano board. So here also we have, it's actually a smaller board. Okay, the size is pretty much less, but it's also powerful. Okay. So these are the major important Arduino boards. Other than that, other than this, there are different other kind of Arduino boards like Arduino Duminolo, Arduino Mini, Arduino Pro Mini, and different types of Arduino boards are available there. These are the important or major Arduino boards which are commonly used. Okay. So we will the thing is that in the case of this Arduino board, in the case of this microcontroller board, we can actually program it. We can actually tell the microcontroller how to work, what all things are to be done. We can actually instruct them. We can actually tell them what is supposed to be done. Okay, so that's what's the importance of this particular development board. Okay, you guys might have heard about ICs. In the case of IC means integrated circuits. In the case of these integrated circuit chips, it's actually designed for a particular task. But in the case of this Arduino board, or in the case of these microcontrollers, we can actually design it. We can actually tailor-made it for our own purpose. So that's the importance of microcontrollers. So now let's do some task using this microcontroller. Are you all ready?
Yes.
Okay. Okay, cool. Is it interesting or is it boring? What do you think?
It's interesting.
It's interesting.
Okay, cool. Okay, nice. So we will just try to do something using this Arduino board. So let me move to the Tinkercad. Can you all see it? Is it visible?
Yes, sir.
Yeah, I will just go back. Yeah, I will just go back. And yeah, at first I will just simply, we will just start with a basic circuit. I have already done it, but tinker this, yeah. So I hope that you guys can do it directly. I think you guys don't require any assistance. If you found it difficult, then obviously you guys can ask me, or you guys can actually start making the circuit. Anyway, I will just show you how it is supposed to be done. Okay, I will just delete this wall code and I will just show you how the circuit is to be done. Okay, yeah. Now we have the fresh working environment. Now what I'm going to do is that here we have the Arduino Uno R3. Can you all see it? Is it?
Yes.
Okay, cool. Okay, fine. So I have took it and I have placed it. And for rotation, I'm pressing the R button. Yeah, not this much. Yeah, I'll just move. Yeah, this is fine. This is the perfect position. Now what we have to do is that we actually have to turn on an LED. It's a simple experiment actually. I thought we will just start from the basics itself so that there will not be any problem for anyone. Okay, so it's a basic experiment only. Those who have already done it previously can obviously start doing right now, and those who haven't done it, those who need some assistance, can actually follow me and try to do it later on. Okay, so what we have to do is that we need to turn on, we have to turn on an LED using this Arduino board. So you can see that there are lots of pins on the either sides of this Arduino board. So I am choosing 13th pin of this Arduino board. Okay, so for turning on an LED, obviously we require a resistor and an LED. The output of this Arduino board is actually 5 volt, which in the case of this LED, it requires only 3 volt. That's the reason why we are choosing a resistor, and we can change the value to maybe 470 ohm. That is only required since it is 5 volt. So we require only say 470 ohm. 470. Can you all see it? Is it visible?
Yes, sir.
Sir.
Yeah. So I have changed it. Now I have placed it near to the 13th pin, and let me start wiring. Oh, I don't need this color. Let me change the color, and now it became red. Yeah. Now let's connect the other part to the anode. Actually, this 13th pin will actually provide a 5 volt. Okay. So I will explain all those things while we are doing the programming, and I'm connecting it directly to the resistor, which has a value of 470 ohm, and the other terminal is I'm connecting it to the anode of this particular LED. Then we have to connect the ground to the cathode. Here I require black according to the convention. So yeah, black. That's it. Here you can actually choose the color of the wire. Okay. Here we have many options. Normally we will choose red for the positive power supply, and ground for the ground we will choose negative power supply. Okay. Here actually in the case of this Arduino board, this ground actually acts as the negative terminal of a battery. Okay. It's almost analogous to the negative terminal of the battery. So we have to choose the ground. We have to connect the ground to the cathode of this LED. Okay. Were you all able to do the connections? Is there any confusion? Anyone? Anyone found it difficult? Is there anyone? Anyone who require any assistance? Anyone? I hope that it is clear. In case if you found it difficult, you guys can ask me at any time. Don't worry. Okay. Now let me just show you how we can program it to turn on the LED. Okay. So for programming purpose, here we have a button, a code button, which is present on the top right corner. You have to click here. Then a window will pop up here. On this drop down window, you have to choose text. Then you have to continue. Then a programming window will appear somewhat like this. Okay. You have to delete that entire code. That code is not required for us. Okay. So that's what we have to do. Were you all able to follow me? Were you all able to complete the circuit? What about you, Vishal? Have you completed?
Yes, sir.
Okay. What about Aishani? Completed?
Wait.
Okay. What about Avani? Were you able to do it?
I am doing it.
Okay, fine. Okay, good. Okay, you can take your time. Don't worry. So once you have completed the circuit making, you can actually open this particular tab, tab, which can be opened by pressing this code button, which is present on the top right corner. And here you will see a drop down menu, and on which you can choose text option. And here we have a text editor. Okay. So here actually we can type the code. According to this code, these codes are actually like instructions. We are actually giving this particular Arduino some instruction that we are actually telling it that you have to turn on this particular LED bulb which is connected on the 13th pin. We are actually instructing it. We are actually giving some commands. So at first, in the case of all Arduino codes, we will have two functions. And the first one is void setup. Then we have two curly brackets. And after that, we have void loop. I'm sorry, I made a mistake. Yeah, void loop. This also has two curly brackets. That's fine. Now, these are the two basic functions which are supposed to be there in almost all the Arduino programs. Okay. Now we have to tell the Arduino board that we are using this 13th pin. Okay, we are using this 13th pin, and we are actually connecting an output device. Okay, the LED is actually an output device, so we are actually telling the Arduino board that we require this 13th pin, and we need to connect an output device to this particular 13th pin. So how can we tell that? How can we give that particular information to this Arduino board? It can be done by typing this code. I'll just type it down. Pin mode. Okay, pin mode 13. We have specified the pin number. Then we have to tell it whether it is out for output or for input. We need it obviously for output. So I have written output. Okay, fine. That's fine. Now what I have to do is that I have to turn on the LED. Okay, I need to turn on the LED. For turning on the LED or for getting a 5 volt on the 13th pin of this particular Arduino board, there is actually a code which is digital write. Okay, you guys might have noticed that I have written this M as capital M. Okay, have you noticed it in spin
Yes,
mode?
sir.
Yeah, it's actually, this case is actually called as camel case. You guys can see a hump in the middle, so that's actually called as a camel case. Okay, so that's about the case. And we can actually, for turning on, there is only a symbol code, which is digital right, digital. In the case of this also, we have to make the R capital, sorry, W capital, digital right, 13 comma high. Okay, so that's all. Now we can actually close this window, or we can keep it like this also. Now we can actually start the simulation. Shall we start the simulation? Are you all ready?
Yes.
Okay, okay, let's start the simulation. Yeah, I have started the simulation. Yeah, is it turned on? Is it turned on?
Yes.
Yeah, it is turned on. Now the next objective is that we have to turn it off after a particular duration, after a particular, say 1 second or 2 second. After 1 second or 2 second, I have to turn it off. Okay, so how can we do it? Let's see how can we do it. Okay, so for that we have to tell the microcontroller that you can actually we can actually add some command which will actually delay the operation of this microcontroller. And the command is quite simple. You have to just type delay, and in the brackets you have to provide the time till which it should take a delay. Okay, so that's how you have to do it. So we can actually provide a delay for around 1000 seconds. Okay, so we can actually provide a delay for 1000 seconds, sorry, 1000 milliseconds, which is actually 1 second. Okay, so that's ready. Then we have to, so it will actually, so according to the first code, it will actually get turned on whenever the system is executing the first code, which is digital write 13 comma high. Then it will execute the next code, which is delay 1000. Then it will actually wait for 1 second there. And after that, we have to actually turn it on. Okay, sorry, turn it off. We have to turn it off. So for that, I'm writing the code digital write, WRI, digital write 13 comma low. Okay, so I'm writing digital write 13 comma low. Okay, okay, so we have written digital write 13 comma low. Then again we require some more delay. We actually want to our task is to actually blink an LED. Okay, at first we have to turn on an LED for a particular duration, say for 1000 milliseconds, which is 1 second. And after that we have to turn it off. Okay, and it should remain turned off for the next 1 second, which is 1000 millisecond. So again we have to provide a delay for 1000 milliseconds, which is 1 second. Okay, now the code is ready. There might be some errors. Let's see whether there is any errors. If there is any error, then we can actually correct it and we can simulate it again. Okay, let me start the simulation. Yeah, there is some error present in this particular code. Let's see what is the error. Okay, just a second. Digital write is fine. The thing is that, yeah, I actually made a mistake here. It should be digital write. I actually wrote it like digital write. Some mistake was there. Yeah, so it is corrected. Now let's start the simulation again. Yeah, again I think there is some error in the function void loop.
Digital write.
Yeah, again I think there is some problem with the digital write. Yeah. Now it should work. Yeah, now it is turning on. Yeah, that's it. So while we are programming, actually we have a syntax. In the case of this digital write, we have to write it as it is. Suppose if I'm changing the W to small letter, let's see what will happen. If the W is small letter, then yeah, it will again show the error. It will actually show that the, yeah, it was not declared in this scope. So we have to change it. We have to write it accordingly. Okay, this is the language which is known to this particular microcontroller board. So we have to give that. We have to give our instructions in this particular language. For instance, whenever we have to talk with a person who only knows, say, Arabic, then we have to, if we want to instruct him, then we have to learn Arabic or we have to talk in Arabic, right? So similarly, this microcontroller knows only this language. Then we have to talk it in this language. The name of this language is actually embedded C. So we should actually study embedded C, and we have to talk to the Arduino board, or we have to command the Arduino board in embedded C. Okay, so that's how we have to do it. Is there anyone who found it difficult? Is there anyone who has any confusion? Now let's check whether it works or not. Okay. Yeah. Now you can see that it's turning on and it's turning off. You can see the simulator time here. It got turned off for 1 second and it got turned on for the other 1 second. It's remained turned on for the 1 second and it remains turned off for the another 1 second. So it blinks. Can you all see it? Is it fine?
Yes, sir.
Okay. Is it interesting? I think most of you
Yes,
have.
sir.
Yeah, I think most of you might have done it. Is there anyone who did it before? I think there might be lots of. It's the basic. Yeah, it's the basic work actually. So you guys might have done it. But don't worry if you haven't done it. You guys can. I hope that it is clear. Is there anyone who found it difficult? Anyone who wasn't able to do it? Or yeah.
Sir,
Yes.
yes, sir. I found the code difficult actually.
Okay, you can actually share. Yeah, you can actually share the screen. Or one thing I can do is that I can actually copy this code and I can give it in your chat box so that you guys can easily copy it and you can analyze it. You can actually check what all things are written on the code. Okay, is that fine?
Okay, sir. Thank you, sir.
Okay, okay, good. I have pasted it in the chat box. Okay, I hope that you guys can see it. Yes, Shavin, thank you for the help. It's actually digital, right? The spelling was mistake. Yeah. Yeah. Yeah, Malayalam is fine, Shavin, but the thing is that there are different peoples from different parts of the country. I think that's the reason why I thought I will just choose English. Otherwise, I obviously prefer Malayalam. Okay. Then I hope the code is fine. Is there anyone who found any other difficulty, like in wiring the diagram, in wiring the circuit diagram, or anything like that? Anyone? Is there anyone who found any other problems? What about you, Anjana? Were you able to do it? Have you got the result?
Yes, sir.
Okay, great, great, great. What about others? What about Vishal?
Sir, no problem.
Okay, fine, fine, fine. Okay, how can I learn this programming language? Don't worry. Actually, we will actually learn this programming language by doing these kind of activities. Actually, okay, that's the easiest way. Actually, we have to. The base is actually C. If you are learning C language, then it's quite easier. But you don't have to go for that. You can actually try to do these kind of projects or these kind of works, and accordingly you can study it. Okay, so that's how you can do it. Now, yeah. So I hope that it is clear. Is there anyone who found it difficult? Anyone? Is there anyone who wasn't able to do it? I hope that almost everyone was able to do it. And let's move to the next task. Okay, are you all ready? Shall we move to the next task? Yeah, okay, okay, cool. So let me move to the next task. Just a second. Yeah. Now we will move to the automatic gate lamp. Okay. So normally in our homes, we have a lamp near to our gate, right? However, yeah, we obviously have lamps in our gate. And the thing is that we have to turn it on at the night, right? And we have to turn it off when it becomes morning, right? And
Yes, sir.
yeah, and it's a daily routine, so it's a repeating task, it's an iterating task, right? So why can't we automate it? Okay, that's the project which we are going to do next. So here we have the Arduino board, obviously, and we have a photoresistor. It's actually an LDR, and we require two more resistors and an LED. In the case of this LDR is actually a variable resistor. The thing is that whenever light falls on it, there will be some change in the resistance of this particular LDR. Whenever light is not there, it will have a different resistance, and whenever light falls on it, its resistance will change. So that's how it works. I hope that it is clear to you. So here we have made a small circuit. It's an easy circuit actually. You can keep the circuit which you made for the LED blinking. You can keep it there, and you need some additional components. Okay, I'll just tell you how you have to connect it. Okay, so first of all, you have to choose the photoresistor which is present here. You have to choose it, and then you require a resistor which has a value of 4.7 kilo ohm. Okay, so we require a resistor with a value of 4.7 kilo ohm. Then we require some wires. Okay, so and the connection is that from the 5-volt pin of this Arduino board, you have to connect it to the one end of this LDR, and from the other end of the LDR, you have to connect it to the end of the resistor, and from there itself, you have to connect it to the A0. Okay, you have to connect it to the A0 pin of this Arduino board. A0 is actually analog pin. Okay, we will study about analog and digital pins later on. Okay, for now, we have to connect it directly to here, and the other terminal, the terminal 1 of this resistor or the other terminal should be connected to the ground of this Arduino board. Okay, is it clear? Are you all ready? Are you all doing it? I hope that you guys are doing it. Is there anyone who found any difficulty? Then you guys can actually ask me so that we can clear it out.
Sir,
Yeah.
I was having a network issue. Can you say one more?
Okay, Hania, don't worry. The thing is that here we have the circuit. I hope that you guys can see the circuit now. Just a second, let me. Oh, I'm really sorry. I think my screen was not visible, I think. Okay. Is it visible now?
Sir.
Okay. You guys might have told it before. I actually thought that this display was shown. Okay, anyway, I will explain it again. So this is the circuit which you have to make. Yeah, so this is the circuit which you have to make. So here we have an LDR. Okay, this is a photoresistor. And in the case of this LDR, actually its resistance value will change according to the light falls on it. Okay, so that's how it works. And we have a resistor which has a value of 4.7 kilo ohm, and the normal circuit which we did before for the LED blinking, that is actually present here. And here we have the input circuit. This is actually the input part of this particular circuit, and this is the output part, and this is the microcontroller. Okay, so that's how it is. Now talking about the connection diagram, you have to connect one terminal of the first terminal of the LDR to the 5-volt power supply which is present on this Arduino board. You can see a 5V pin on this Arduino board, and the other pin can be connected to the connected to a terminal of this resistor, and the resistance value should be 4.7 kilo ohm. Okay, and the other terminal of the resistor should be connected to the ground pin, and you also have to make a connection from the point where this LDR as well as the resistance are connected. You have to connect it to the A0 pin, to the analog 0 pin of this Arduino board. Okay, is it fine? Is it okay? Were you able to understand the circuit? Is it fine?
Yes, sir.
Okay. Then you guys can actually try out the circuit. And if you found it difficult, you guys can obviously ask me so that we can clear your confusions. Are you all doing? I think that you guys are concentrating on the work which you are doing. Okay, it's good. Try to do it as fast as possible. Is it boring?
No, sir.
Okay. I actually thought that it will be quite better to what we can say, instead of simple demonstration, I thought that it will be better to let you do something, right? What do you think? Is it better to do like this or just simply hearing the class? Which is better?
This is better, sir.
Okay. The thing is that we can actually, instead of just simply hearing, you guys can also try some new things here. And in this case also, if we are making some mistakes, we are not going to lose any components. In the normal scenario, what happens is that if we are making some wrong connections, then this Arduino board might get burned. It costs around 300 or 400 something. So the original board costs around 1,000 or something. I think there will be duplicate boards which are available at 300 or 400, and the money will be lost if we are making some wrong connections. But here, there will not be any problem if we are making the connections wrong. So the thing is that we can actually, whenever we are making some circuit, we can actually try it out at first in this particular platform, and then we can try it out in real. Okay. So what do you think? Is this platform fine, or do you find it perfect to do these kind of activities? What do you think? I hope that most of you are busy with your task.
Sir, will you see my circuit? I have
Yeah,
tried.
yeah, sure, Gautam, sure, Gautam. You can actually you can actually mirror your screen. You can share your screen. Go on. Those who have completed can obviously share your screen so that it will be really nice. I can actually see what you have done. It's really nice.
Sir, I am screen sharing.
Okay, Gautam, just a second. Until now, I can't see it. Let's wait for some more time. Okay, by the way, Gautam, where are you from? Hello, Gautam, can you hear me?
Yes, sir, I am from.
Yeah.
Sir, I am from West Bengal.
Okay, Gautam. You can actually share your screen. You can try to share your screen. Until now, it didn't come. We'll just wait for some more time. You can try to share it. Okay. Meanwhile, is there anyone who found it difficult? Anyone? It's actually easy, right? Is it easy or is it hard?
Easy.
Yeah, that's it. Actually, we can do lots of experiment even using this itself. We have lots of components in it.
Sir, now can you see?
No, Gautam, I can't see it. Yeah, it's coming, Gautam. It's coming. Yeah, I can see it. Gautam, the circuit is somewhat fine, but you have to make one more connection. One more connection is to be made from the middle terminal of this particular, from the terminal which is connecting. No, not there actually. You have to connect it from the terminal, from the place where the LDR as well as this resistor is getting connected. You can actually choose the, not, I will just show you. Don't worry. Just a second. I will just share my screen so that you can see it. Okay. Okay, can you see my screen? Is it fine? What you have to do is that you have to make a connection from this terminal. Okay, which is the terminal, which is the thing is that you have to make a connection from this terminal to the A0 pin of this Arduino board. Okay. Now you can change the color using these options, this drop-down menu, which is present on the top right corner of this, top right side of this particular site. Okay, is it clear, Gautam? Is it fine?
Yes, sir. Thank you, sir.
Okay, Gautam. Okay, you guys can actually try it out. Take your time, don't worry. Meanwhile, if you have any confusion, you guys can actually ask me, okay? Is there anyone who has any confusion? Anyone? What are you all doing? Okay, we will just wait for some more time.
Sir, I have finished.
Okay, great. Those who have finished the circuit making, I will just show you the code. Okay, I will just show you the code so that you guys can try out the code. Okay, just a second. Just wait for a while. So yeah. So here in the code section, this is the code. Actually, I'm not going to type it again because we might require some more time. We don't have enough time, so I'm not typing it again. Instead, I will just explain you what I have written in the code. Okay, here we have the void setup and void loop, as in all the programs, all the Arduino board programs. And we have obviously declared, we actually told the Arduino board that the 13th pin of this particular Arduino board is used as output pin, and we require an input pin, right? We are using, which pin we are using for input? Can anybody make a comment?
A0.
Yeah, here we are using A0 pin as input. So we just gave the instruction that microcontroller, please make the A0 pin as input pin. Then here we are using serial. This is not required actually. For now, leave it. We will actually study about all those things later on. And then we have void loop, which is the next function in the Arduino Arduino programming. And here actually we are using a new function, which is called as analog read. What happens is that if whenever we are using this command, it will actually check the voltage which is present in this particular pin A0, and accordingly it will provide a value between 0 to 1023. Okay, we will study about all those things later on the continuing sessions. Okay, so that value will be actually stored in this variable. It's actually a variable. Int means it's a variable whose data type is integer. Okay, you guys might have studied about variables in your mathematics class, right? You guys might have studied about variable x, variable y. Have you studied?
Yes, sir.
Yeah, then what's the peculiarity of this variable? How it works?
Negative, positive, and 0.
Yeah, actually the thing is that it can store some value, right? The variable can store some value. X equal to 5 means x has 5 inside it, right? So similarly, here the variable is actually a. It has some value stored in it, and the type of the variable, it can only store the values which are of the type integer. You guys might have studied about integer also. So this variable can only store the values of the type integer, and the value which we are getting from the analog read A0 command will be stored in the integer a. Okay, so that's all about this particular command. And the thing is that if we are getting a, whenever some light falls on it, actually the resistance will change. Then accordingly, the voltage which is coming on this particular pin will actually change. That's how it works. If the voltage is if the light is very low, then what happens is that the voltage will be low. and if the light is higher, then obviously the voltage will accordingly change. So that voltage change can be understood by using this command. Okay, so that's the importance of this command, which is written over here. And on the next line, we will actually check the value. We have set a value of 500. As I have already mentioned that the value of this analog read will fall from 0 to 1023. So what I thought is that if it is falling below 500, then we can assume that the light is, there isn't enough brightness, there isn't enough light. We can assume like that. Actually, it will happen like that. Whenever the light is less, then the value will be somewhat below 500. So there actually we are checking using an if condition. We are actually checking whether the value is below 500. If it is below 500, then the light is obviously less. Then what we have to do? Then the thing is that whenever the value is below 500, the light is low, which means that it is dark, it is night. So what you have to do? You have to turn on the light. So for turning on the light, which command can be used? Can anyone of you suggest me? Can anyone of you tell me?
Digital right.
Yeah, obviously we have to write digital write 13 comma high. If it is 13 comma high, then it will turn on, and if it is 13 comma low, then it will turn off. Okay, I hope that it is clear. And after that, I have put some delay so that it will remain turned on for a particular duration. And I have put this else condition. Else condition actually, if this if condition is not satisfied, then this else condition will get executed. And in this else condition, we are actually turning off the light. So what happens is that if the value is above 500, which means when it becomes morning, when it becomes early morning, there will be enough light. So this value will be anyway more than 500. So if it is more than 500, then these all commands will not get executed. Then directly the command which comes after this else will get executed. So this command will execute it. And what does it mean? Can anyone of you tell me? Yeah, it's actually for turning off the light. So whenever it becomes morning, it will turn off the light. So it's actually to automate the gate lamps which are present in our home. Okay, it should be turned on at night and it should be turned off in the morning, right? So let's see whether it will work or not. Were you all able to complete the circuit making section? I'll just copy this command and I will just paste it so that you guys can easily get the code. Okay, I have pasted it. Okay, while copying, you have to start from the void setup, and there is a curly bracket down below. You have to copy till that. Okay, so that's what you have to do. Now, shall we try? Shall we test it? Are you all ready? Are you all sleeping?
Yes, sir.
Okay. Okay, fine. Then let's try it out. Yeah. I have started the simulation. Yeah. Now we can actually, we don't have a light source or we have the option to change. We don't have the option to detect a light source here, but instead in the simulation software, we can adjust the light source here. Now the light is very low. Okay. Now the light is very low. It's dark. That's what it shows. Here you can see a dark mole here. Now the thing is that here the light is turned on, right? Can't you see it? Are you able to see it?
Yes, sir.
Yeah, now it is turned on. Now let me try to, now it becomes morning. Let's make it morning. Yeah, now what happened?
Light turned off.
Yeah, when it becomes morning, then it gets turned off. Now again, on the next day, whenever it becomes at night, let's try. What happened?
Light turned on.
Yeah, that's it. Is it interesting?
Yes, sir.
Yeah, we can actually do all these things in real also. It's easier. The circuit is the same. You can do as we did here. You don't have to change anything. You can do it directly as we did here. You can choose the values of the resistor accordingly. Okay, so that's how you have to do it. Have you ever done this before? Is there anyone who had done this circuit before? I think there might be, since there are students from the Innovation Hub, we have done this before here. Right?
Yeah.
Yeah, we have done it here, but afterwards we can actually try it out. Whenever you are coming here, we can actually try out more interesting projects. Okay, so is there anyone who had any confusion regarding the session which we took today? Anyone? Any confusions?
No, sir. This is my first time, and I enjoyed very much. Your instruction was so well. I did it. I enjoyed it.
Okay, thank you, Gautam. Thank you, Gautam. It's really pleasure to know that you were able to do it, and you guys can actually, we will actually continue these kind of sessions in the future also. Okay. Meanwhile, I will actually share your feedback form so that you guys can actually tell me what did you felt about this particular class. Okay. So I have, yeah, I have shared the link here so that you guys can go there and you guys can write the feedback. Okay. Okay, fine. Then, is there anyone who found any difficulty in doing this particular project, the last project which we did? If you have any confusion, we can actually try it out. We can actually clear it. Anyone? Who all did it? Can you just tell? Who all did it? Okay, Asil did it. Then Vishal was able to do it. Then what about others? What about Aishani? Were you able to do it?
Yes, sir.
Okay. What about Anjana? Anjana, were you able to do it?
No, sir.
What happened, Anjana? May I help you?
Sir, I was facing a lot of network problem.
Okay. Don't worry, Anjana. Don't worry. You can actually try out the code later on. Okay. I hope that you have got the code, right?
Sir, this is my mother's phone and I am Adyasha.
Okay. Don't worry. Okay. You can actually try it out later on. Okay.
Okay, sir. Thank you, sir.
Okay, thanks. And what about Najwan Asan? Were you able to do it? I think there is a connectivity problem. And then what about Hania?
Yes, sir.
Okay, good. And what about Neha TV?
Yes, sir, I was able to do it.
Okay, good. Then Asil, I think he was able to do it. Then what about Samuel? Samuel, were you able to do it?
Yes, sir. It was really good. I enjoyed it.
Okay, nice. What about Shahwan Asan? Shahwan, were you able to do it?
Yes, sir.
Okay. Then what about Shavin? Shavin, can you hear me? Hello. I think some connectivity problem is there with Shavin. And what about Tirtha?
Yes, sir.
Okay, fine. Oh, okay, Shavin. Okay, good. Okay, good. Okay, fine. Then what about Kiran? Kiran, were you able to do it?
Yes, I was able to do it. It was an awesome session, sir.
Okay, nice. Okay, thanks. Then what about Mariam? Was it fine? Oh, I think there is some connectivity problem. Okay, I hope that it was fine. Then we can meet in some another session. So you guys can actually share your feedback in the feedback section in the link which I have shared. Okay. So that's all about it. Now we can actually stop. Yeah. Yes, Anjana.
Feedback form.
Okay. Thank you, Anjana. Okay, thanks. So that's how it is. And sir, can you send it? Yeah, sure. I will send the feedback link again. Don't worry. Just wait for a while. Feedback is actually good because we can understand how the session was. Just a second. I hope that you can see the. I will just share one more link so that it will work in a much more better way. Just a second. Yeah, you can use the second link, the final link which I have shared, and you can submit your feedbacks. Okay. Meanwhile, mm, in which classes are you studying? Like, are you all from the high school or from the? Is there anyone who is studying in +2 or +1 or some higher classes? Okay, Niharika is in 8th. Then what about others? Are you all in the high school?
Sir, I am from class 6.
Class 6. Okay, okay, great, Gautam. Then what about others? Hania is in 8th standard. Vishal is in 10th standard. Okay. Anjana is in 7th standard. Okay, cool, cool, cool. Okay. Okay, nice. It was actually a nice session with you. You guys were very responsive. Neha is in 10th standard. Okay. Okay, okay, nice. Then we can actually, yeah. Oh, okay, okay, Anjana. Yeah, I remember. Yeah, yeah, I remember your name. Your name is Adyasa Das, right? Okay, okay, Anjana. I was, okay, Adyasa. Okay, fine. So we can actually wind up the session, and we have, Aishani is in 6th, Tirtha is in 8th standard. Okay, okay, cool. Okay. So is there any certificate, e-certificate? I think there will not be any e-certificate for this program, but we used to conduct some program which in which we used to give e-certificates. Okay, so that's about e-certificates. My name is actually Joel George. I'm working here as a innovation hub mentor here, junior mentor. So we have an innovation hub here in Regional Science Center and Planetarium Calicut. You can actually take even you can take the membership here. So I think the membership is for 1 year. So that's how we used to take classes like this on weekends. I think I think Asil used to come here on weekends, right? Asil and even Vishal Kamath, Tirtha. I think you guys were there, right?
Yeah, I used
Yeah,
to come.
yeah, we used to have weekend classes at first, but later when this COVID came, we actually shifted to this online platform. And in this online platform, we used to take daily classes actually. During the previous lockdown time, we used to take daily classes on electronics and all those things. But later, when the third wave came, we stopped for a while, and now we are actually planning to start it again. Okay, so shall we stop it? Shall we stop the today's session? Yeah. Okay, fine. Then see you guys. It was a nice session with you. Yeah. Okay. Okay. The thing is that you can use the website anytime. Okay. You can don't worry about that. You can use the website anytime. It's not at all a problem. Okay. 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 Thank you all. You guys can leave actually, and we will meet on some other sessions. And along with that, we have classes on the next days. The schedule is actually shared with you. Okay, you can attend other sessions. We have classes on chemistry as well as a final session on collisions. Okay. Will we have a continuation of this class later? Yeah, we are actually planning to continue this session later on. Don't know when we will be able to continue this session, but I will try to inform you. Okay. What is the login process? What you have to do is that you have to go to this particular site, and the site link is, I think, you just have to type Tinkercad. That's all. You have to type there, type on your URL, and what you have to do is that you have to, as and when you open this particular site, you will have an option to sign in using your Google account or Facebook. I think I don't remember it well. So you can choose either this Google or your Facebook. And what you have to do is that if you are already logged in your browser, then automatically you will get signed in. Otherwise, you have to provide the credentials for your Google or Facebook. Then you will automatically get signed in to this particular site. Okay, that's how you have to do it. Okay, thank you, Aishani, thank you, Kiran. Okay, thank you, Adisa Das. Okay, I hope that it is clear. Those who have the confusion, those who have any confusion, can remain here and ask me. Others can leave. Okay. 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 Thank you all. Thank you all. Thank you, Neha. Okay. Those who have any confusion can remain here and others can leave. Okay, we will then stop the session. Thank you all. It was a nice session.